Back to topic, AI and APIs. This is a combination I think we cannot avoid. My name, as mentioned, Murali Sitaraman. I'm a technical specialist. The senior title is by experience, not by age. But I covered the whole integration portfolio in IBM across EMEA. We support customers, partners, colleagues across the region. And that makes it very interesting and exciting. I learned there's a rule of 3. It seems people cannot memorize more than 3 items, so I stick to that. I'll give you an intro why we're talking about these two topics of APIs and AI together. I'll show you what IBM is doing in terms of supporting API developers at design time to create or develop those APIs, and then what are we doing at runtime, because once you've designed your API, you're enforcing them on your gateways, there has something needs to happen that stuff works. Before we get into that, a little bit about me. My looks give it away. I'm Swiss. Did my schooling in Switzerland. I did some steps in the mobile area, selling logos and ringtones. The older ones might remember those times where we spent an awful lot of money to customize our phones. But that was basically my first touch point with APIs without knowing it. At that time, if we had an RFP out there for some solution, the answer, there's an API, was rather a curse than an opportunity for us. I moved on, joined IBM, floated around in that whole SOA topic. Integration started being a constant with me. Moved a bit in the direction of BPM, business rules. Came back to a mobile topic again with the mobile application development platforms that were floating around for a few years. And obviously, that was the next touch point with APIs. Moved on from there to go to the broader set of integration capabilities, and ended up being a co-author on an integration modernization red book that's still out there and valid. And the fact that there's quite a number of authors also shows how complex that topic is. But we want to talk about AI and APIs, and this is basically the space we're in. So we have a life cycle for APIs, create, secure, manage, test, socialize, and discover. And that, on one hand, can be supported by APIs, but by AI, sorry. And on the other hand, we have these APIs that can then call AI models and consume these models. So it's a bit of chicken and egg. Where do I start? But these are the two levels, and we have the different levels of APIs, obviously system APIs, business domain APIs, and then app-specific and dynamic APIs that we're dealing with. Now, we have this hype cycle from Gartner, so we have the Gen AI-driven API generation that's already beyond the peak of inflated expectations. We have the AI gateways and the API consumption by generative AI in the innovation trigger space. Now, if we all agree with that, that's a different question, but that's what Gartner tells us. And that's the mindset we're going to move along. The other aspect is there are estimations saying 75% of developers will be using a code assistant by 2028. And there's some other number out there that we expect 8 billion new applications by 2028. So that's virtually 1 app per inhabitant of the world in the next 3-4 years. I think it's ambitious. And if you think about it, what would you do with that amount of apps? But yes, define an app as a collection of 3 microservices that have an API. We have the number going. The other side is we expect, or it's expected that there's a 36% productivity gain by using those code assistants. So we have a first expectation of what these code assistants should deliver us. And this is literally the value of those code assistants that we're looking at. I think the top ones, as the tip of the iceberg, are fairly easy to understand, and they all are linked together. So there's faster coding that leads to time savings, that hopefully leads to cost reduction. But there's also a dimension that we're not seeing at first sight, that is improved quality. possibly improve developer retention because the surrounding these engineers work in is favorable for the employer as such. And obviously, the reduction of bugs or the number of bugs that come up. Having said that, I would be also careful because the code that comes out of the code assistant is only as good as the model is that's underlying. So if you have a defective or a faulty model, you're impacting your quality at the end. So be aware of that. It's not a savior across everything, I would say. Now, we have a generic view on how AI and integration play together. One is integration enabling AI, and AI empowering integration, and we can apply that one-to-one to APIs as well. So let's start on the AI empowers integration with the focus on APIs. That's really where, how do I enable developers to be quicker, possibly at a higher quality in their output, and a higher quality in the end for the consumers as well. And again, these are the expected outcome: speed, having innovation, and then an important aspect is the skills dimension. I don't need the deep specialist for AI to do these things each time, or I don't need the deep integration specialist to do these tasks each time. So in theory, I'm stressing that in theory, each integration should be less costly for me, because hopefully I can give this task to someone who's less skilled, but I have more people available with that skill, and they can do these tasks. That's the idea behind it. Now, we have these personas that we look at: the business technologist or the business analyst, say a tech-savvy business person that we somehow all need to be in today's world, I feel. We have the app or the API developer. We have an integration expert. These are the guys that have been making a living for the last, 20, 25 years, knowing one product to the core, to the last bit and byte. They're still needed because there are always cases where you cannot do it with a low-code, no-code environment or something that has not been captured in an AI model. So don't write them off. And then obviously the operations side. This is not what we're going to look at today, but there's also a lot happening on that side. So there's a lot we're doing in IBM across the integration portfolio. I want to focus on the, is that color? Yeah, yellowish. API Assistant top left, design time, automated test creation, auto test assist, and AI insight-driven test generation, all are design time aspects, and then the advanced API security and AI gateway as runtime dimensions that we're looking at in these areas. Now let's start with design time, creating an API. Again, we'll start here on the create for the lifecycle. And what happens there is basically the API assistant pops up as an add-on within the UI. This is basically a browser-based UI that an API developer would see. And there are recommendations that can be given based on the API definition. That's a very simple one. That's the Swagger pet store definition that's been pulled in. And then there's a generation of these ideas. Okay, we can extend the description to make it more meaningful. But then here at the bottom, we also have certain suggestions for creating examples for the schemas that we're using. And this addresses, obviously, the number one topic, or let's say one of the two topics developers love, documentation. The next one is testing. So if you have a solid foundation here with examples, it makes it potentially easier for someone else who has not created this API definition to understand what's happening here. And yes, some deliberately don't do that to save their job. But that's a different dimension to look at. And then once we're happy with those recommendations, we apply them, all good. Now, this is the first step we're looking at. Within our product development teams, we're looking at the idea to go a step further to detect faults. So as of today, if you, say, validate this API definition against OpenAPI 2 spec, 3 spec, it will tell you there's a fault in line X, but it will not yet suggest you the correction of that. So the next step is to have that correction built in as well as part of the recommendation. So it's a bit twofold. One is recommendation on the documentation side, and the other one is the correction piece that will then make you have a valid API definition that can be used. So once we're happy with our API definition, we look at how do we test that thing. So test cases is something, by experience, that's very hard to find all the angles that you would test something with. We have this thing called automated test creation, where I need either an API definition or an endpoint. I throw it at the tool, it generates a test case, which allows me to test the APIs for quality. So it's not a status 200 that you see, it's a status 200 plus. These are the responses that have come. And if the responses are as expected, the test case passes. If the test case fails, that doesn't mean the API is not working, it means the response is not as expected. Now I have two options. I adapt the test case, or I investigate why the response is not what I expected. And there's simple examples like postal codes vary across Europe. Some use digits, some use letters and digits. So if I have my test case generated with something, say Germany, where I have, I think, 5 digits, that will be the test case. Now, if a Swiss consumer comes or a Swiss address comes that has 4 digits, the test case will fail. These are the nuances we have to be aware of before cursing the tool. I did it myself, by the way, but these are then the different levels of tests that I can create. And then, obviously, each test case can be grouped into larger test suites, and the test suites, in turn, can be run via an API. So this can be part of my pipeline. Each time I run my test suites, it's regression testing. And there's nothing more hated by teams, I would say, than regression testing, because you're forced to deliver new stuff. Now, having done that, that's the first step. And the other side is running these test cases with, say, trying to find the limits. So that's then what Auto Test Assist provides. That's really the fuzzy testing in terms of, can this thing deal with special characters? Can this deal with characters from a different language? And I know what I'm talking of. In Switzerland, we have 4 languages, French, Italian, German character sets. So yes, sometimes you forget the French special characters, it will fail. And these are the things we're looking at. We run these test cases, and ideally, they all pass. And if not, obviously, we have 2 hints again. The test case is not set up correctly, or it's, in fact, the API that is not delivering the correct results here. This is all nice. We're now ready to publish these APIs. Now, what we've taken this approach a step further is to connect actually the runtime traffic to the test cases in an on-prod environment and identify a delta, and then suggest from that new test cases to increase test coverage, because it can be that my assumption or my view of the world is not entirely right, and the runtime behavior is different to what we see or what we expected while creating those test cases. So if there's any gap, there will be a suggestion to create new test cases to decrease that gap and increase test coverage, again, in turn, benefiting for subsequent releases or subsequent versions or other of APIs. Now, we have published our APIs, and now we have two aspects, basically, of what we're consuming. One is, I would say, standard services, REST APIs, so backends, GraphQL, endpoints, for those who have been in the session today morning or in the workshop yesterday with Michael and Benedict, they would have heard about that topic. And then we have AI models. And this is basically the idea behind it, to have that abstraction layer around all the AI models. Small disclaimer at this point, currently we're able to work with Watson X. This is our platform, but then we're also looking at market demand. We have an early adopter program or early experience program, consider it a beta program, where customer have the chance to influence our direction by saying, we want, I don't know, Gemini, we want the meta model, we want this. So that's where we then take customer feedback and we'll enhance the AI gateway's capability in the corresponding direction. And the AI gateway as such does nothing else but what an API gateway does for backends in abstracting the endpoint from the model I'm calling. As simple as that. Plus, it gives me that single place to subscribe to an AI model. I don't really have to care where it's running, which is the model that's there. I should care about the functionality that I'm getting. The second is consolidating buying power. So if we have 10 departments and each department has its own subscription, and I think the classic example is something like a Google Maps key. 10 departments have their own subscription with Google Maps. If we can consolidate that, get a higher volume, possibly get a better deal with the provider, that's the approach here. Once we have that as well, there's analytics. So we want to see when are these models used, by which applications are these models used, how often are they used at all? These are questions that have an impact in, does it make sense to maintain these models? If they're not used at all, why waste money and time on that? My experience is operations would send an email to a distribution list. They would ask, hey, is this application still being used? If no one answers, they'll shut it down, and you can bet that person who uses that app was on holiday and comes back and says, hey, where's my application gone? And these are the things we don't want to happen. We want to be able to have an informed decision, as it's called. So that's where the analytics piece comes in and provides us, and you'll go to see how that all looks just in a bit. And then there's the aspect of rate limiting. So running workload on AI models can be costly, depending on what task you run. And we have implemented a special way of enabling that rate limiting, which is very similar from what we do with GraphQL as a backend. And if we assume that we have done everything, we obviously want to publish these AI APIs, if I can call it that way, into a self-service portal where then app developers can go and consume those APIs. This is a bit more detail on how we do the rate limiting. So we assess what's the payload that's going in. So am I sending, I don't know, temperature of Berlin for the last 30 days into the model, and I want, give me the average temperature. Well, it's a bit an overkill to use an AI model for that, but we could do it in Excel. But let's take that as an example. So the amount of data I'm sending in is, say, 30 lines or 30 items. What I'm getting out is one number. So we have, say, 30 tokens going in, one token coming back. And this is what we're looking at in terms of allowing that rate limiting. Yes, you can still do the classic X transactions per second, but you might pay a price on your backend. And the tokens are then there to say, I'll give you 200 tokens a minute, an hour, whatever the unit of time is. And that will then allow me as an application developer to either say, I'll have 10 requests per second, I have 2 requests per second, depending on how heavy they are. And with that, I'll show you how the visualization, hard word, looks of these things. So once we have these calls coming in, we have our AI gateway that is able to measure these calls, the payloads going in and out, obviously give me the token values, and then this will be visualized as a heat map. So I can see at what time of day are these models used most, which applications are using it, which of the models are being used, and so on. But instead of having that as slides, I want to show you this. If all goes well, yes, the video is running. So this is our UI for API Connect. We create a new API spec for the AI Gateway, which is an OpenAPI 3 spec. And as I said, it's currently working with watsonx. So I give it a name, very creative. And then we need an API key that watsonx requires. We have this as a SaaS service running. We choose the region. We need to enter that date there. Say next, it'll create the API definition after me confirming, or my colleague who created the video actually confirming the security, and then the option to say the rate limit, either X transaction per second or set the token limit value on a unit per time, or time unit rather. So once this is done, we have the API definition created, and what we then see is basically that we can use this now to test against it once we publish it, which happens fairly quick. We publish APIs into a product. A product is a logical container to have one or multiple APIs in it, and visibility is who can subscribe to these APIs. We'll let it all default. We publish into a sandbox container. It's anyway the easiest in that respect, but we see the API is published in its version 1, and we have a subscription on it, so we can leverage that. We need to cheat a little to go to our internal developer portal to access the API. We log in. Now we all know who my colleague is. That's our CTO for integration, by the way, but he also does a lots of hands-on work still. And this is my AI API I've created, or he has created an application to consume that API, takes the client ID, copies it, or pastes it in there rather. And we're now simulating the client application basically. And yeah, it's an easy question. We say which AI model are we using, tell me what to do. We see the token that we set as a maximum, and that's basically our subscription. The response comes back, and we see the input token was 10 tokens, and the response was 59 tokens. Not entirely sure about the maths on this, but we see it was fairly quick. The first request was 2.5 seconds. We have caching built in, so subsequent requests are processed quicker for the same requests, so you don't have to waste CPU cycles on answering the same requests there. And obviously, if I exceed my token limit, I won't be able to call that AI model for a certain time. And as mentioned, once these calls have been done, we want to see the usage. Again, this is about seeing what models are being used, which applications are using it, what are the response times, what are the tokens that are being used. And this is all information that gives us a foundation to take an informed decision in say, the life cycle of these APIs, life cycle of the AI models. Which one should we touch? Is it possibly sensible to let an AI model or an API run in an older version when we know there's a peak usage of these models at, in this case, right after lunch? I doubt that is realistic, because mostly after lunch we're a bit slower, but it can happen. And this gives us really the idea on where to tackle or where to evolve these APIs or the AI models. And then obviously we have the consuming applications, HR team, payroll team, I know it's small, logistics team, so we can use this for internal costing, for example. So that's another dimension that comes in with having this kind of information. I can identify the applications that are using the AI models, which model, and then decide, do I want to build them internally? It won't be the favorite possibly, but that is the approach here. And the left pie chart is really about which model are we using within that, now in this case, Watson X. So we have the Meta, Google, FAN, and the IBM Granite model there. And then this is also how often do we hit the cache, so we have an idea on how many similar requests are we getting. So is everyone asking what's the weather tomorrow? This will spike. And these hello world kind of examples will obviously most likely hit the cache again, so the caching will benefit again by protecting the backends from additional consumption, or rather CPU usage there. And then we have the response times, and some of them are a bit higher because depending on the token amount that has gone in, it'll take longer to process, and these at the very low ones are really the ones that hit the cache, so you also have an idea on what's happening there. And then the same is then displayed as percentiles on token and or request and response, I have to say it that way. So we have the full view on what's happening there. It seems like a lot, but this is really to provide the full, say, insight in what's happening on the topic or on these AI models, especially if we are not in control of consuming them. Now, that is one aspect. We're shielding our AI models. The other one is more on the classic side of classic backends. We have a partnership with Akamai on a topic called Advanced API Security. That's a solution that allows us to hook in with either API gateways, load balancers, firewalls, and create an inventory of APIs, because it is assumed that not every API is managed in an enterprise. Surprise, surprise. So this allows us to discover all these APIs, build the inventory, take it a step further, assess the data that is sent over those APIs to see is there any sensitive data. Are we going against any OWASP rules? Are we abusing any other rules in terms of, say, credit card data, social security numbers? And these data models are all predefined in the solution already, so they give you a quick view of what's happening, and then it allows to decide, number one, should we still have those things? There are industries that run a Christmas promotion, an Easter promotion, applications are being published, they're taken down after Christmas period or Easter period, and most likely people forget about that application that's still running. And no one has taken them down, but they're still accessible if we have the right way in. And that's one aspect, and the other one is it detects attack patterns after a learning phase, like low and slow attacks. So I, as an attacker, can call the same API, let's say every Monday morning at 8. I try to find my way in. Now, if I use it standard API usage data, I just see it's being used. Potentially, I see the client ID, yes, but I don't see that this is a pattern over multiple weeks where the same client ID is trying the same API with maybe a different payload to see what happens. And these are things that can be detected here and obviously then flagged, raised into whatever, a Jira ticket or a ServiceNow ticket that can be then taken into a remediation of that issue that can be then published. Or, as in our case, we can do this immediately with our gateway. We can block these consumers. The gateway will fetch the latest information every few minutes to then block these malicious attacks. And with an eye on time, I'm getting to the summary. AI is a hot topic. We're looking at really time savings and powerful outcomes with code assistants helping us, and there's a vast variety of code assistants out there. We're looking obviously at enabling AI with integration, meaning feeding data into these AI models to train them, to make them better, not to have just this version 1 of a model and then let it be. We want to improve, adapt in that sense. And the third one is really to empower integration by using AI to make life easier for the API developer or the app developer that has to do integration tasks, and potentially they'll end up doing integration without really knowing it. And with that, I can take maybe a question or two.
First of all, thank you very much, Murali Sitaraman.